We usually think of AI models as being like cameras, right? They just passively observe the world and make predictions. But what happens when they stop being cameras and start being, well, engines? What happens when they actively shape the very world they're trying to predict? Okay, let's dive into this because it's a fascinating paradox.
So this whole thing starts with something you probably use every single day. Your navigation app says, hey, there's a huge traffic jam ahead on the main highway. Because of that warning, you and thousands of other drivers get rerouted onto side streets. And what's the result? Well, the original prediction, that big jam on the highway, never actually happens, precisely because so many people listened to the prediction and avoided it.
Now let's really raise the stakes. Imagine an AI model flags someone who just lost their job as being at high risk for long-term unemployment. So, because of that prediction, they get fast-tracked into a special job training program. And guess what? The training works. They land a new job quickly. And just like that, the model's initial prediction is proven wrong by the very action it triggered.
Well, it turns out this whole idea has a name. It's called performative prediction, and it's basically any forecast that just by existing changes how people or systems behave, and in doing so, completely alters the final outcome. The prediction isn't just a spectator here, it's an active player in the game.
And this is where we hit a massive paradox for machine learning. See, a model is trying to learn the basic facts of the world, what data scientists call the ground truth, but its own predictions are constantly rewriting that truth. Seriously, it's like trying to read a book while someone is literally rewriting the pages right in front of you.
And that brings us to the really big question, right? How on earth can we build a reliable AI if the very data we need to train it is constantly being warped and changed by the AI's own influence? This, right here, is one of the biggest hidden challenges in AI today.
All right, to really get to the bottom of this, we need to talk about a core concept in machine learning called generalization. At its heart, it's pretty simple. It's all about asking, how well can a model take what it learned from a small test group and apply it to everyone else out there in the real world? Think of it like this. An app company might roll out a new feature to a small test group, the sample. Let's say it's just their users in San Francisco. Their ultimate goal, though, is to predict how that feature will work for the entire population. So, everyone in the whole Bay Area.
I mean, this is totally standard stuff. You learn patterns from your small, controlled sample group, and then you generalize those lessons to make predictions for the much bigger, messier population. It's the bedrock of how this all works.
But here is where performativity just throws a giant wrench in the works. What happens when the model's predictions start changing the behavior of the test group in San Francisco and the wider population all over the Bay Area? All of a sudden, that simple, straightforward act of generalizing becomes a total nightmare.
So, what does happen? Well, the research we're digging into here found a pretty startling answer. This isn't just some small technical glitch. It actually reveals a fundamental trade-off, a hard limit on what these kinds of influential models can ever really do.
And the core finding is this: the more influential your model is, the more it successfully gets people to change their behavior and alters outcomes, the worse it gets at actually understanding what's really going on. It's a direct, measurable trade-off. The more a model changes the world, the less it can reliably learn from it. It turns out that changing the world and understanding it can be two completely opposing forces.
And check this out. This graph from the study shows it plain as day. Let's go back to that job seeker model. Okay, look at the bottom axis. That's the percentage of people who get job training. As that number goes up, as the model has more impact, now look at the blue line. The model's learning error also goes straight up. The conclusion is pretty hard to miss. More impact equals more error.
All right, but believe it or not, it gets even weirder. The researchers pinpointed a worst-case scenario where this feedback loop doesn't just create errors, it creates outright deception.
As the paper itself puts it, the sample can deceive you, creating an empirical echo chamber. This is what happens when your small test group and the wider population start reacting to your predictions in completely opposite ways.
And this is where things get really wild. Look at this dangerous split. In your test group, your sample, the prediction becomes self-fulfilling. They do exactly what the model says, and the data makes the model look like a genius. But out in the real world, with the actual population, the prediction becomes self-negating. People do the exact opposite, and the model is a total failure.
Let's bring back our navigation app. So imagine in the San Francisco test group, every single driver follows the app's new route perfectly. Traffic flows beautifully, and the data coming back says, wow, this model was amazing. But in the rest of the Bay Area, drivers are skeptical. They ignore the app's suggestions, creating total chaos on the side roads and making the model's predictions completely useless where it actually matters.
Okay, so if the data is basically lying to us, what are we supposed to do? Are we just stuck? Well, this is where the research gives us a really surprising and honestly powerful insight. The solution is the exact opposite of what you'd probably think.
Your first instinct would probably be, okay, let's just feed all this new change data back into the model and retrain it, right? But the study shows that can be a huge mistake. If you retrain your model on data from that empirical echo chamber, you can actually make it even better at being wrong in the real world. You just amplify the deception.
The real value isn't in the distorted data itself, it's in the distortion. By carefully observing how the data changes in response to your model, that's when you can start to measure your model's true impact. The shift in the data, that becomes the signal, not the noise.
So, this all leads to a practical two-step plan. First, you deploy your initial model, the one that was trained on the original, clean, unchanged data. Then, and this is the key part, instead of just retraining, you use the changes you see in your test group to estimate just how big that performative effect is. It tells you how much your model is really changing things.
So the big takeaway is this. You just can't blindly trust a model that's been retrained on a reality it helped to create. What you can trust is the data that tells you the story of how it created that new reality. You have to measure the impact, not just learn from the manipulated result.
And that really leaves us with a pretty deep final question, doesn't it? As AI gets more and more woven into the fabric of our lives, what's the right way to measure its success? Is it all about pure predictive accuracy in some sterile, isolated lab? Or is it about the quality, the fairness, the desirability of the world that its predictions actually help bring into being?
All the ideas we've talked about in this explainer are based on some really groundbreaking research in performative learning theory. So a huge shout out to the authors for pushing the boundaries and helping us all understand the true impact of AI.